All right, so I am here. Come from a company called SparkCognition. And many of you probably don't know about us. So we are a startup based out of Austin, Texas. We were founded in 2013, and we provide like AI-based pipelines and solutions as products. So our main products are we have an automated model building module called Darwin. We have a machine learning antivirus called Deep Armor. And we have an NLP product called Deep NLP. And so I'm here to talk about one of our advanced POCs that's kind of ready to be shipped called Project Minerva. And so my background is I went into theoretical physics, and I've been a data scientist since 2015. All right, so what does Minerva do? So what we have found is like we've had a few one-off consulting jobs, and it turns out a lot of the time what they have are just big feeds of lots of text, and they kind of just plop it on our lap and say what you want to do with all of this stuff. And so most of these data sets tend to be super repetitive when we've gotten them, and so what the end user really kind of wants is find something interesting, and so we've kind of chosen an anomaly detection type workflow. And the other thing that we have gotten a lot of is, so we'll have like financial clients that are like, what does this correlate with? What can I use to make a decision based on this? And so we've been also kind of interested in doing various sorts of regression sort of analysis using this plaintext. And so the basic workflow that we go through is that we go and extract a bunch of features from the text, and we then do some unsupervised learning to kind of find the anomalous stuff, and then we extract some features from it to do the regression. And there's some more stuff that we will get to sooner. And skip that. All right, so here's the basic idea of everything is that we have this big kind of complicated workflow. So the whole thing is sort of, what's nice about the whole thing is that we are pretty much just using Spark libraries. So this whole thing was built using that Spark ML, and we were able to kind of patch together a bunch of Spark stuff and get pretty good results nearly out of the box. And so we kind of start with our raw data feeds, and we've used a variety of like basically news sources is 90% what we have, and we've used different news feeds with different results. But we've also done a couple of POC type things using, so there's this corpus called the Abbottabad corpus that the CIA seized from Osama bin Laden when the US went after, and then they released a bunch of it to the public that's been redacted. And so we ran this against this, and it worked relatively well. So we at least know that it works on Arabic text documents as well as English. And so yeah, so then the idea is we take this raw corpus, and as with any ML, you start with raw data, and your raw data is not usable, and like most of what you do is in feature extraction. And so what we did first is we just trained a word-to-vec model against our corpus. Because, well, for one thing, you'll see later that the algorithms we want to use, the linear structure of the linear outputs of word-to-vec, where things like inner products are important, was useful to us. And the other thing is that it was just there out of the box. So we kind of additionally wanted to train a glove model, and we just ran out of time. And that'd be a future extension of the thing. And so we feature extract from our raw text using word-to-vec, and we basically translate each document into a daily average, or into a document per document average. And what's nice is because, you know, things like vector differences are important in word-to-vec, then if you use something like k-means clustering that's based on like a normal Euclidean distance metric, then everything just kind of works naturally, and you get good clusters out of it. And so we can then go and like do our anomaly detection right away, because you get these word-to-vec averages per document. You go and cluster all of your documents, and then if you go and do counts, your document clusters end up in these nice power law-y type distributions. And so right away you can see that like cluster 67 there is your normal document, right? And then these other guys are your anomalies. And so when your end user is like, what documents should I read that are different than this like giant pile of stuff, you've got a bunch of clusters that you have for them to go through. So then once we have our clusters, we can then go and calculate a bunch of metadata. And what's even kind of more useful for us there is you can then leverage all the time series nature of your data, right? Because now that you have a clustering model that's based on your documents, you can then go and say, okay, what days are interesting in your data set? So you go and group all of your documents by day, right? And then you can calculate a daily average across all of your documents. You can then run your clustering model on that, like this already trained clustering model that you have lying around. And the daily averages still form this nice power law distribution that you saw before. So you have a bunch of days where the news looks normal, and then a bunch of days where the news looks crazy. And if you want, you can go and supplement this with like things like document counts or number of characters in the day, and get the same sort of features to go and do stuff with later. So okay, so now and furthermore, when we went through and did the clustering on these results, we actually found out that, hey, these clusters end up having like real semantic meaning. So this is just this is like a real result I just pulled out of the hat of like the first cluster I looked at to draw this talk. But we had a list of named entities, right? And then we ran the clustering algorithm against the word-to-vec embeddings of those guys from just this plain text document, no special sauce, just out of the box word-to-vec. And first cluster I looked at, you get about 15 entities in there, and they're all kind of like this. So you have a bunch of board of governors, heads of central banks, that sort of thing, just living in a thing. And like the other ones kind of look the same sort of thing. Like you had one that was like all oil companies. And so that was pretty neat and somewhat unexpected how well it worked out. All right. And so now for the time series regression bit. So there the workflow that we used was slightly different. So we have our daily word-to-vec averages, right? And then what we did is took those daily word-to-vec averages, and for this, like, we ended up not even needing to use that many components. I think we used 5 components in our word-to-vec vector. And so it kind of was just like a natural feature reduction as much as anything, because we're not trying to do like text prediction or anything like that. We're just trying to find what's important in the data. And so we took those, we had a daily average of our word-to-vec components across all documents for a given day. And then we had, the idea is that we'd ship this to consultants or somebody. Like this would be a tool for consultants to use. And so the case study we were doing was on the price of oil. So the idea is that these consultants would know something about oil. Right? They wouldn't just be a dumb user at your like spitting your data science wisdom out. They'd like have some value add. So we envisioned that they'd have a bunch of keywords they were interested in. So in addition to like these daily averages of our components, we would filter our corpus by a set of keywords that they were interested in, right? So they'd like have, you know, Venezuela and Aramco or whatever. They'd have these pre-filtered keywords. They'd enter that in, and we'd filter out the things and then calculate our Word2Vec components of only those documents that contain the words of interest to them, plus like some forward filling in case there was a day that those words didn't appear in the corpus and stuff like that. And so doing that, then we go and ship the output data frame to Darwin, which is our automated model building tool, which Darwin kind of behind the scenes does the same sort of thing that like Teapot or one of these tools does, but it also has a bunch of like recurrent neural networks and things in its toolkit, so it can custom build a neural network based on the data that it's given. And so when we went and did this, we then went and tried to just predict, okay, based on all of this text data that we have for today, what is going to be, can we predict when the price of oil is going to change by more than 5% the next day? Right, we picked just a hard cutoff threshold and turn all of our y variables into 1 zeros. And so doing this, we were able to get like a 55% AUROC, which sounds bad, but for financial data, which is super noisy for the most part, it's actually generally a pretty good result. Like anything that beats randomness at all is considered a win. And so, hey. All right, and so that was basically the end of our POC. And then we had a bunch of and what was nice about the system is that it was simple enough because it was all just built using like out-of-the-box Spark stuff that we were able then over the summer to hand it off to interns. And they could run it on these additional data sets, like this Abbottabad like counterterrorism data set, and we used a few other open source data sets that we could just get for free. And they were able to go and run all of this themselves, able to do analysis, and then they also went and added some topic modeling to the clusters. So the first workflow I had to kind of go through by hand and look at, okay, this is the cluster about the Federal Reserve, this is the cluster about the oil companies, so on and so on. But these interns were able to go and just run an LDA on top of the, you basically treat every document in the cluster as a single document. And then they just ran an LDA on that. And they were able to do topic modeling, and the topic modeling they got out was relatively sensible. And kind of for the future, what we really kind of need to do with this is just experiment with other vectorization techniques. Like, it's working relatively well, but I'm convinced it can work better. And we're running into like some retraining problems with it. And so with that in mind, we basically just need to extend this a little more. All right, and I went and blathered super fast, so I am done. Are there any questions?
Thanks, Jerry.
So k-means, Spark's k-means working really well for Word2Vec vectors is really counterintuitive and surprising. Did you look into why that happened, why that worked?
So it was bisecting k-means. It wasn't the center. So and kind of the motivation there is that I've always kind of done better with these hierarchical clustering models than I have with like just, bald k-means type stuff. So I don't have a ton of insight as to like why this worked as well as it did, but it did just work really well.
Mm-hmm. If you have a question, raise your hand.
Have you tried any like pre-trained word embeddings data set, or pre-trained ones instead of just the Spark out-of-the-box word2vec library?
So for our deep NLP product, that is generally what we do. We use a pre-trained glove over there. And for this POC, we were trying to just kind of let the data speak for itself as much as we could and try to kind of build models that were specific to the data set we were using. So we did not use any pre-trained models, but that's certainly an extension we could use.
Hi. The number of clusters that you use on k-means can have a profound effect on your anomaly detection later on. Can you give us some insight on the selection of clusters and how you go about the whole process?
Yeah, so we did kind of two things. The first thing we did was just the normal elbow method thing, where we just chose a bunch of different k's and looked for like the one that looked at the second derivative of the objective function and picked the one where you had a sudden, where we stopped increasing k when you got diminishing returns in like the performance of the objective function. The other thing we did is we just ran this entire pipeline, right? And we ran this entire pipeline, adjusting the word2vec components and adjusting the number of k-means clusters until the output we got from the thing looked sensible. And that was one thing where this regression workflow was very helpful, because when you're doing a regression, the regression either works or it doesn't. And it's much clearer than when you're doing this unsupervised type of learning, where you can kind of convince yourself that your clusters look reasonable, because there's no like null hypothesis of these are dumb clusters. And so having the regression workflow was real helpful in doing this hyperparameter tuning. And so that's basically the two things we did.
Thank you for your presentation. Two questions. First question, what type of news feed did you use? Specialized news or more generalistic? Mm-hmm. And from how long did you take the news? And the second question is, when you say you predicted the change in price variance of oil, did you predicted this for the next day or for the closure of the price of the same day?
Okay, so the first question is, what newsfeed did we use? We used a variety of different newsfeeds. So we had a static data dump from this newsfeed called WebHose that kind of would just sell us a bunch of data at a fixed price. We also did a brief POC with Bloomberg using the full Bloomberg fire hose. And so that's why we went to Spark in the first place, is because that's the only way we could even start to handle the Bloomberg fire hose, is using the Spark stuff. And yeah, and then we've used a bunch of variety of static data dumps. So we did this about data set. We worked with, there's an open source of, is everyone here familiar with the Enron thing? So there's a company called Enron in the United States that collapsed, and like their emails were made public by the SEC. And so we were able to like work with like all of the emails with this largest corporation. And so we used a variety of different exact news sources, but that's the basic idea. And I forget what your second question was, I'm sorry.
Sorry, my second question was about, when you say you predicted the change in variance of price, did you predicted it for the next day or for the end of the day? So using the news of the day. Yeah.
So what we did is we counted, we had to like care about market close. So what we did is, if the news came out, we had to prorate the news to be the previous day. So we predicted basically the change in oil price between the day after. So if market closes at 12:30, news article comes out at 11:30, then I'm predicting the change in oil price between tomorrow and the next day.
Thank you.
And we also tried various other offsets, but tomorrow and the next day was the one that worked best and didn't involve using the future to predict the past.
Okay, what was interesting for me, the last thing you mentioned, the LDA. Mm-hmm. So if maybe you could elaborate a bit on that, how it works combined, because I'm just thinking about it. If you do word2vec and some clustering on top of that, in essence, that is also some kind of like topic model. So if you could explain how like these two things work together, LDA and the clustering, and what each of these was actually telling you.
Okay, so you're correct that like basically we already had kind of a topic modeling idea there. But the idea is that this LDA analysis that they ran already assumed that, like, basically the idea was you created these clusters, right? And you have all this word-to-vec and clustering on top of it. You've built up all of that, and then this intern project basically treated these clusters as static, just collections of documents that as far as the LDA algorithm was concerned, didn't know that they were already generated by some ML thing. They were just, you have a bunch of documents in bins.
Okay, so it was like done separately per cluster, you
Correct.
could say, yeah? So we had like several LDAs for each of the clusters?
That's correct.
Ah, okay, good. Thanks.
Any other questions?
And the motivation there was to like not use bias from all the stuff that we use to generate these clusters in order to bias the explainability model. Like that we're kind of honestly looking at it without double dipping into our ML stuff.
I have a basic question. You know, the first part was about the clustering and finding out anomalies in the text corpus.
Yes.
And second part was predicting the, the change in oil prices using regression. So how does these two combine together? So what from the first you used as a features in the second one?
So that's a good question. So basically these are two different workflows that exist in the same dashboard.
Okay.
But the core idea is that the whole thing is based on these word-to-vec components that we were generating. So once you have these word-to-vec components, you can either use them to go and build a regression, or you can use them to build a clustering model.
Okay.
And so we're using word-to-vec as basically just a generalized feature extractor from this like fire hose of text data.
Okay, so you have word-to-vec model, you have embeddings, and then in the second case you had this time series, right?
Yes.
And you're trying to predict the next day's changing. And you're using regression model for that.
Correct.
So, but how does this first part, the signals from the first part, which is your word-to-vec embedding, feed into the second part?
Oh, so I have this word-to-vec embedding, right? And I
Yeah.
have a bunch of documents that have a bunch of embeddings, right?
Okay.
And so then I can take a daily average
Okay.
of every document that appears on January 22nd. I average all of their embeddings together, and I get a single embedding for January 22nd
Okay.
per like topic keyword,
Okay.
right? And so then that's just basically a bunch of features that I can then run against my
Yes, sir.
time series.
Okay. All right.
You said that that you broke the data up into the individual days. So did you combine all of the news articles in a given day to form one document, or did you? I mean, did you? Yeah. So how exactly did you do that?
So I computed embedding averages per document, right? And then then I averaged all the documents for a given day.
Okay.
And
And those actually, and you managed to cluster those, and they formed useful clusters.
Yeah, they definitely formed useful clusters. Like, they all some of them were junk clusters. Like this giant, what we found is that the 994 cluster kind of was sort of if it didn't know what to put something in, it ended up in that giant cluster.
Right.
But the other clusters, for the most part, looked semantically meaningful like this.
Okay, and also you said something about you picked certain keywords when you were doing the oil price prediction.
Yes.
You picked certain keywords like Venezuela.
Well, the idea in the product is that the end user would pick these certain keywords.
Oh.
So, we'd have a dashboard, and they'd have a list of, things that appeared n numbers of times in the corpus. And then the end user would be an oil expert or whatever Y variable we're predicting. And they'd be like, okay, Venezuela and Saudi Aramco are hot in the news right now. Let's build a model around them, right? And then they'd say, and then they'd enter these keywords in the UI and generate the regression that way.
But then what do you use those, how do you use those keywords?
So I do that same procedure with the daily averages, except I average by day and by does the document contain that keyword.
Okay, so you eliminate any documents that don't contain the keywords that don't contain the relevant keywords.
And in principle, we could do some sort of like relevance score on top of that and weight the documents by relevance score, and we just ran out of time and didn't do that.
Okay, thank you.
Thank you. Maybe sound a bit naive, but I was wondering how did you exactly do the, how did you combine and aggregate to daily level? Because for news, could be that a news that comes up at 10 p.m. it's not relevant to that day, but to the next one. And when we are dealing with news from all around the world, it's not always trivial to say what is the day of an article. So how do you deal with that?
So we were lucky enough that all of the things we work. So in Bloomberg, everything is just GMT. And so it comes to us in public, like when Bloomberg found out about it in like UTC units. And so we're able to just normalize to UTC, and then we know when the market closes when we're doing this Y regression, and we can just say, did this happen on the day before the market closed or the day after the market closed, and we can just normalize the day that way. And yeah, that's basically all. We just kind of normalize to UTC and know when the Y variables happen and normalize everything that way.
Thanks for the talk. I think I understood now that you didn't use your clustering for the regression, but you just took all the whole news of one day to compute your mean. But did you play with kind of if you have a cluster for each day and kind of match up clusters from different days, that you get a time series of a cluster mean or something like this?
Oh yeah, so yes, we did do that. And the kind of reason I didn't talk about it as much is the idea there is that we'd go and like have these days that alert stuff. But it turned out that these daily cluster averages did not predict the oil price. So if you ran it through like even when we were doing just simple linear models and we ran it through like just something like a PCA, the cluster number would always just drop off. And so it didn't seem to be important, so I didn't include it.
Okay, we got time for one more. Okay, no more questions. Oh, one more.
So I understand that regression model, like the building of regression model is a result of user input. So it's done in a real time. How long it takes to build that model, and how many simultaneous users do you support, whether it does not create a load on the system.
Okay, so running a single model is probably 15 minutes or something like that. It's not horrible. And the way Darwin works is that you send your data up through an API, and then it goes and like builds the model on a remote server. And so it's not being done locally at all. And most of that 15 minutes is like just dealing with data throughput stuff. And we haven't done like massive load testing on concurrent users, but it's all kind of run in parallel on Spark, and we're pretty convinced that we could go at arbitrarily high if we just added more servers to the cluster.
Does it auto-scale automatically?
It does not auto-scale.
All right, so everybody give Jerry a hand. Thanks.